This is Ramulation Padi, lecture Department of Civil Engineering from Ganesh Institute of Engineering Technology. So we are going to discuss about the slump cone test, which is a part of building material and concrete technology. So like slump cone, let's understand what is slump and what is cone. As you know, we in various kind of site we used to test some concrete before casting. We test some concrete test that the concrete is applicable for our site or not. Like this, slump cone is one of the test which in where we check the consistency of the concrete. Is the concrete is workable for us or not? For this purpose, we do one test is known as slump cone test. So, what is slump? Let's understand. First is think the concrete. The concrete is the fresh concrete which is unsupported fresh concrete. First one is, if we see, this is one unsupported fresh concrete. And the second thing is its flow to the side. And the third thing is its shrinkage its height after removing the mold. These three phenomena will define the slump. These three phenomena which is created in vertical side, these three phenomena known as slump. Let's understand what is this. First is unsupported fresh concrete. First thing, what is unsupported? In slump cone test, we use one cone type of mold. After removing the mold, the concrete is totally unsupported. No mold is there, no reinforcement is also there. So we tell that unsupported fresh concrete. Second thing is flow to the side. After removing the mold, as the concrete is casting on movement, there is no hardening point at there. So the flow is the concrete, the fine aggregate, the fine particle which we use like water and cement and fine aggregate, that flow to side. And the third thing is its shrinkage is height. Like the cone we use, the height is like 300 mm. The height is 300 mm. After removing the mold, the concrete, as it is not hardened, we remove the mold. The height of the concrete is shrinkage towards the bottom part. This three phenomena is known as slump. These whole three vertical phenomena is known as slump. And let's understand why to use this test. Now, if we talk about why to use this test, as we know, the aim of experiment is to determine the consistency and consist or workability of fresh concrete. So the part is consistency. What is consistency? As we know, we prepare a concrete like after mixing the fine aggregate, coarse aggregate, then cement and water. This is the whole proportion is create a concrete mix, and the consistency is like the water we added. Is it applicable for the site or not? if the concrete is the consistent of the concrete is applicable for the site, like we construct one slab, we construct one beam, we construct one wrapped foundation, pile foundation. Is the construction at the construction site, the consistency is good or bad for this site? So this is we test for the consistency of concrete. And the workability. What is workability? This is the main part which we try to understand about the workability. Workability is one part where we can discuss about the concrete is workable or not. So how we know the concrete is workable or not? Like in today's generation, we normally use RMC. RMC stands for R for ready, M for mix, and C for concrete. It is a in previous generation we prepare some concrete on site and on casting site, but nowadays we use some ready mixed concrete which is prepared in plant, then transferred to the site, then the casting is done. So in that criteria, the plant is maybe far from the site, maybe closer to the site. So in the travel portion, the concrete may be hardened. If the consistency is not good, the workability of the concrete is reduced. So in that, the workability is known as first mixing of concrete in plant. We mix the concrete. We mix the concrete without water in the plant. Then we transport the concrete in a van or in a vehicle to the site. And inside we add water to see the weathering condition of the site, see the casting substance of the site. Then we add water to the concrete. After casting, if we see there is some segregation, there is some bleeding point, so the concrete is not suitable for our site. So we do some pre-test to know that the concrete is good for our site or not bad for our site. So this is one sort of from test by which we found that yes, this concrete is for our site or that concrete is not for our site. So the workability is the concept where we try to know that the concrete is the consistency, the water content of the concrete is in proper for the site or not suitable for the site. And this is the workable. This is all about the theory of this Crompton test. Now we go for the apparatus required for the apparatus which we need for the Crompton test. First, we need the basic apparatus is weighing machine. The weighing machine, and second thing is mixing plate, and the third thing is trowel, and the most important which we do in this test is slump cone and their apparatus. One slump cone, then is base or tamping rod. This apparatus we required for our slump cone test. First thing is weighing machine. To prepare the concrete, how to know that this concrete is M30 grade, M35 grade, M25 grade? There are several grades of concrete. The applicable for the site, there are some different applicable for the concrete mix. So for weighing machine, we used to measure the aggregate, we used to measure the cement for the concrete and the mixing plate. But where we mix the concrete, And the trowel. Trowel is the basic thing by which we mix the concrete and pour the concrete to the mold. And mostly slump cone and bed. There are the conical shape mold which is known as slump cone, and its base is mostly required for the test. And tamping rod. Tamping rod is one manually vibrator by which we by using tamping rod we remove the void from the concrete. That's why we use tamping rod. So now this is the slump cone, how it seems like. Now this is the slump cone. And this part is the metallic base. And another one is tamping rod. These all things have their standard dimensions, which decoded by the Indian standards. First thing is the slump cone. The uppermost diameter is 100 mm. This lowermost diameter of this cone is 200 mm. And the height of this cone is 300 mm. And the tamping rod which we use to the tamping rod has two uses. First one is to remove the void from the concrete, and second one is to measure the slump value of the concrete after demolding. So the tamping rod also has a standard size. The diameter of the tamping rod is 16 mm, and the height of the tamping rod is 600 mm. This is the main apparatus which we use to do the slump cone test. This is the slump cone. This is the handle. After to demolding process, we use this handle to demold the slump, and this is the metallic base, metallic plane base, with which the concrete stops from slump to the base, and it is a tamping rod by which we remove the voids from the concrete, also to measure the slump value from the concrete. This is the apparatus which we require to do the slump cone test. Next thing, now we move towards the procedure. Procedure is like, first we have to mix the concrete. If we used to mix inside, we need suppose we need M30 grade of concrete. Then there is a proportion is 1 is to 1.5 is to 3. That means if we add 1 kg of cement, then we have to add 1.5 kg of sand, and then we have to add 3 kg of coarse aggregate, by which we mix the concrete for M30 grade. For this process, we need to use weighing machine in this test. Now let's proceed. After mixing the concrete, we have to clean the slump cone. We have to clean this cone in a clean properly to this floor, to this cone. After cleaning, we have to pour the concrete in the mold. We have to pour the concrete in four times, and 1/4 time we have to pour the concrete in the whole cone. We have to pour in the whole cone. We divide the cone into 4 parts, and in one part, if we pour the concrete in one part, then we have to use the tamping rod, and then we have to pour 25 strokes in the whole surface, not in one surface. We have to tap in the whole surface by using the void which may create in the concrete. The void is totally removed. As usual, we have to pour 1/4 time to the 1/4 time for one time to pour the concrete and tamping for 25 strokes for each layer. After after reaching the topmost part, we have to clean the topmost part with an towel or anything. We have to clean this. After this, we have to demolding the slump cone, which is maybe if we do any kind of fault, maybe the cone is collapsed. So we have, without any vibration, we have to demold the slump cone vertically, and after demolding, we find the concrete is in the mold shape, the one conical mold shape, and then after we find the slump value. How to find the slump value? After demolding, we have to see what is the condition of this concrete. What is the condition of this concrete? If the concrete is in segregation criteria, what is segregation? Segregation is one phenomena by which the finer particle of this concrete is separate from the coarse particle of the concrete. And bleeding is one concept where after casting we found some water content which may be shown in the topmost part of the concrete level. So if the concrete is not segregated, if the concrete is not bleeding, then the concrete is we find the concrete is a conical proper shape. So how to know there are true slumps there or else? So the result is, we found the result is like this. What is the result we find? We find, usually in concrete we found four types of slump value. First one is zero slump. If this is the mold, if this is the mold, and after removing the mold, the concrete is as the concrete stay as the mold is there. The shape of the mold is the concrete which gain the shape of the conical shape. This is still like the conical shape. There is no shrinkage of the height. This is known. We know this one is zero slump. After measuring, what we found, this is the 25 mm to 50 mm. This is known as zero slump. Means the mold size is equal to the specimen size. There is no shrinkage of height in this mold. And the second thing is true slump, which normally we usually find true slump for if we found any true slump for the site, then if we found any true slump value which is properly for that site, and how to know this is the true slump or not? After removing the mold, the specimen should shrink. The specimen should have shrinked some height, and this shows like that. The height is reduced from the slump cone to this kind of portion. The inner part may be this is looking like the true slump. And the value is vary from 50 mm to 100 mm. It is true slump. And this is the two kind of slump. The third kind of the slump is shear slump. Shear slump is looking like the one side of the specimen remains constant and another side is shrinkage too much from the true slump, like this. This portion is this is the core slump core. Then the shrinkage this is the shear slump is looking like this. Means one side of the one side of specimen is failure as in shear force. This is the failure as shear force, like and this is the shear slump. And the value varies from 100 to 150 mm. And lastly, there are a concept of collapse slump. By which the consistency of water, the water content is the water cement ratio is too high, by which the specimen of the concrete after demolding is collapsed. Like there the value is varies from 150 to more, and this is known as collapse slump. There are 4 types of slump value we found after slump cone test. Every type of slump specimen has their different kind of uses or for different kind of works. If we see first, as we find the true slump as the best slump value, so we use this slump as RCC custom reinforcement. Concreting, then we casting some retaining walls, beams and slabs. This is the use of true slump. If we see about the zero slump, we use zero slump in construction of road, construction of pavement, and we use shear slump in situ piling, and putting foundation also. Putting foundation. And the collapse slump, we use the collapse slump, the concrete which collapsed after slump cone. This is we use for temporary works. This is for temporary works. Now, how to know the water cement ratio? What is water cement ratio? As you know, water cement ratio is the ratio of in concrete the water content divided by the cement, which is found that water cement ratio. Means if we add any that much of if we add 1 kg of cement and the water content is 0.50, water cement ratio is 0.50, then what is the weight of the water? Like if we divide this 1 kg 0.50 is half of 1 kg of cement contains 500 grams of water. This is the 0.50 water cement ratio. In true slump, the water cement ratio is 0.50. In collapse slump, the water cement ratio is 0.80. It is larger than 0.80. ratio is too low, this is maybe varied from 0.20, and the here now the water content ratio is 0.70. And this is all about the slump test. Wow.